Hello and welcome to another episode of Ken Training. Today's training, what we're going to do is we're working on the water system entering into this house. This is my house. This is a DIY project, and if you look at my channel, Ken Training, you'll see where I went and reconfigured this water system entering into the house, and I reconfigured it so that the irrigation and the house was under the same PRV pressure reducing valve. Now, camera operator, please go ahead and zoom in here so that they can see the incoming water pressure. You'll see here on this gauge that the street incoming water pressure to this house is approximately 120 psi. And come on over here to the downstream of the PRV pressure gauge. You'll see here that we're about 65 psi, and go ahead and zoom back out. So this pressure reducing valve is taking incoming street pressure of about 120, and I've got it set on the set screw right here to knock it down to 65 psi, which is a good pressure for the house. Here's my problem. My problem is that it's too weak of a pressure for the irrigation system. There's 3 valves here, and I've got 3 valves that are in the backyard. Now I'm going to show you the particular zone that's bothering me and what is prompting this whole project, and I'll show you that on the video right now. Okay, so here in the backyard, they had the original irrigation zone under all 1 zone valve. I have since disseminated it so it's under 2 zone valves. But if you'll notice, go ahead, Mr. Camera Operator, put it over here. You'll notice I've got a dead spot over here, and you'll notice that I've got a dead spot over here. And you'll see the flags that I've got here in the lawn, and those are where some of the sprinkler valves are located. So what's happening is I was going to make a repair to the sprinkler irrigation where the pop-up valves are located, the spray heads, where the spray heads are located, and I was going to change those to try to get better coverage to get rid of these dead spots. But let me show you how weak the water is back here. Now I've got one of those internet irrigation controls called Rakio, and so I can do it right here on my phone. So I'm pulling it up right now, and I'm going to do what they call quick run. Go ahead, Mr. Camera Operator, show it right here. So I pulled up the Rakio. I'm going to hit quick run. I already know that this is zone 1. I hit next, and I'll just put it on for 5 minutes, and I hit run. And now you're going to see this zone 1 operating. Alright, so here you're going to see zone 1 right now. And Mr. Camera Operator, what I want you to do is I want you to go where I've got those 2 flags in the very far corner. And do you notice how this area of those sprinkler heads, the water is so weak? Go ahead and come back to me. So you'll see on those 2 sprinkler heads especially, this is just an example, but this is a very good example. Even with 65 psi feeding this sprinkler zone as well as all the other zones the way I have it set right now, you can see how weak the pressure is once the water has to go through all the piping and the 1/2 inch PVC or 3/4 to 1/2 inch PVC or whatever. My goal at the end of this project is to get this pressure, and especially noticeable in these 2 sprinkler heads, to a pressure that I consider reasonable. That to me is unreasonable, and that is what is prompting this project, to get the irrigation pressure up. So that's why we're going to remove the PRV valve from the irrigation system. We're going to allow city water pressure, which in this case is 120 psi, in order to hit the entire irrigation. Okay, so what we're going to do on this project is I want to get a higher pressure inside of this irrigation line. The house pressure, which I currently have set at 65 psi, That pressure is fine. The house, all the fixtures in the house are good at 65 psi. So what I'm going to do is I'm going to take this incoming pressure of 120 psi and I'm going to feed the irrigation system with that. And I'm going to do that by taking and removing this valve and relocating it to here. That gives me incoming city pressure going to the irrigation system, and that gives me the pressure reducing valve here. Now when I do that, I need to relocate this gauge here because I need to monitor the pressure after the pressure reducing valve. I could capture it here, but the way that I operate is I like to keep my gauges on the system at all times so I can just walk by at a glance and I know exactly what's going on. So this house is ready to have the water shut off. I can break into the system and I can move it, and that's what we're going to get to right now. What we're going to do first in order to do this job is we got to shut the water off. So this is the incoming city water right here at the bottom. We're going to go ahead and shut that off. Now we got to get the pressure out of the line set here. Now the water that's in the house I'm fine with. I don't need to mess with that, so I can shut that there. Now on my particular setup, I've got it set up so that I've got bleed valves here on these particular ball valves. So when I bought my ball valves, I bought ball valves with bleed valves. So I can go ahead and undo this bleed valve and I can get rid of this pressure. Okay, let me go ahead and shut that from the irrigation system. And now I've got that, I've pulled off the bleed port off of this bottom ball valve so that I can get rid of the pressure that's just in this line set here, because that's all that we're removing. I've got this valve off, as you can see. I've got this valve off, and as long as these valves are tight, you know, I got water in the hose. No, that actually doesn't matter. The hose pressure doesn't matter because this valve is off. I'm surprised we have so much pressure right here, because all I should be emptying is just here. This is off to right there. Maybe one of the valves isn't tight. I'm not sure. Alright, now that that's off, I'm going to remove this top bleed port, and that will introduce air into the system and allow all of this to open up. Okay, now that that's happening, I'm going to go ahead and I'm going to pull out this valve set right here. Let me get my wrenches. Cut. Alright, the first thing that I want to do is I want to remove this portion of this plumbing piping system which holds the PRV, because I want to relocate this up here. I don't want to heat up the rest of this joint here, so what I've got here in this bucket of water is I've got a wet sock. So I'm going to take this wet sock, I'm going to put it basically here, because I want to heat up this joint, but I don't want to heat up the rest of everything else. So I'm going to just put a wet sock around it like this, just to keep this area here as reduced from heat as much as possible. I just want to heat up this one joint here. Now, for some reason I don't know if this valve is not shutting 100% tight, but I'm getting dripping water on my job, so I can't have that. So I'm going to go ahead and put this bleed screw in on this top ball valve and hit that tight so that doesn't drip on me. And then I've got a couple of dry rags here. I got my heat ready to go, and I got some channel locks here so I can try to pull that off, and then once I pull it off, I'll wipe the solder joint down. So what I'm going to do is I'm just going to put some gloves on, heat up this joint, and hopefully I'll be able to get it off without because I want to reuse these fittings. Right? My intention is to reuse them. Alright, so I've got my wet sock here, and I want this joint protected because I want to break that joint. So what I'm going to do is I'm going to take this, bring it up here, and I'm just going to wrap it around here just to protect all of this. The only joint that I want to disturb is this one right here. And I'm pretty much just going to do the same technique right now that you saw me do here, except I'm going to do it here. One more thing. There's a valve seat on this. I'm going to get one more sock and I'm going to put it on this here to protect this valve seat right here. The two socks in place. I got the heat ready. I have my flux brush right here ready to go. I'm going to go ahead and heat this up. And basically I should be good to take it off. Okay, I can tell that I'm not getting this pipe hot enough. Now, this water in here may be messing me up. So what I'm going to need to do is I need to make sure that this water is 100% empty. So what I'm going to do is I'm going to open this up and I'm going to open up the bleed ports here on the sprinkler system. And let me open up one of the valves here to try to get any water that's in here out. Let me remove this bleed port here. And let me see if I can do it this way. But I'm having a heck of a time, and I can tell that I'm not getting it hot enough by my actions. You have to get it hot enough in order for you to do your work. So I'm going to try it again, see if I can get this hot enough. Now, I'm starting on the inside pipe here, and then I'm moving it out to the fitting to try to get the heat in here. If I have to, I'll move to something more. By the way, I should mention that I'm using MAP gas for the gas for this, which is a hot gas. Okay, I'm not accomplishing my goal with this here. Okay, I can tell with this technique that I am not getting this joint hot enough with just using this MAP gas. There is too much copper, there is too much water, there's too much going on here that with this alone I will not get that joint loose so that I can pull it off with this. So I'm going to get oxyacetylene out here. That will definitely get this pipe hot enough, and I will get that joint loosened up and removed. So what I'm going to do is break right now, and I will get the oxyacetylene, and then we'll introduce the video once I get that. Okay, so now that I've got my oxyacetylene, let's go ahead and see if we can get this thing to work. Alright, I'm going to try that. This should be hot enough for me to get it to flow. Let me get some flux ready just to loosen this up. If this is really hot, this oxyacetylene, I should be able to accomplish this goal. I've got to make sure I don't keep the heat in one location. Okay, there it is. Alright, let me get that off. And I'm going to keep the heat on it gently because I want to wipe that solder down. Like that. Alright, so I know that I'm going to put the pressure reducing valve here, like so. By the way, as long as I've got it off, I'm just looking at the screen inside. Everything looks good. There's no There's no blockage or anything like that inside. Go ahead and zoom in right here, Mr. Camera Operator, so that the audience can see the spring, the screen. Can you see that?
Yeah.
All right, I'm going to turn it around so you can see what the other side looks like. And you can see the there's a like a disc in there that goes up and down. So that's what the pressure reducing valve, how that operates. And here you can see the arrow. I need to make sure I put the arrow in going that way when I go to install it. Now, before I go ahead and cut the copper pipe here, I might as well go ahead and use the emery cloth and just clean this off, only because it's so much easier to work with it when it's already on here. So I'll just go ahead and clean this whole thing off and get it nice and clean. Because one thing I want is I want the copper to be nice and clean for my soldering. So I'll go ahead and hit it really well with emery cloth. Alright, so I'm here on this nut right here, which is the ring after the packing ring, and I'm going to loosen that up. Hang on. There we go. There it is. Alright, now you see there how I'm pulling that apart? I'm going to pull this out, and you see that? There's my rubber ring that I'm trying to protect. Plus, there's another gasket in here that's orange in color. I want to protect that. So now, inside here, there's no rubber. I don't have to worry about overheating this and destroying anything that's rubber. So I'm going to take my rubber guts of the valve and put them aside for now, just to put them out of the way. Alright, so now I'm going to de-ream this. Now you can see the curls that I'm creating. You got to make sure you keep tension on there, and it doesn't take much. See the curls that I'm taking off there? That's the ream that I'm removing from the inside of this pipe. So I'm just going to go ahead and de-ream that. And because even though this here is going to go on the outside of this copper stub out, the reason why you want to pull out the ream is because the ream will create a water vortex and the water won't flow as smoothly inside the pipe. So when you cut the copper pipe with your pipe cutter, you want to de-ream it or ream it. You want to ream the pipe to get rid of that lip so that you don't create any type of internal vortexes and your water flows as smoothly as possible. And then you can just, clean inside there really well and everything. Please. Okay, so this is a solder that we're going to be using. Go ahead and zoom in. And it is just a simple Home Depot solder that is lead-free solder is basically what it is. And this is how thick it is and so forth. Now when I do my soldering, if on a 1-inch pipe, normally you need 1 inch of solder to do one joint on a 1-inch pipe. If it's a 3/4 inch pipe, it would be 3/4 of an inch of solder. 1/2 inch pipe is a 1/2 inch of solder. So you only need, let's just say, about that much solder at the most to do a 1 joint on a 1-inch pipe, which this is 1-inch pipe right here. But so I'm just going to have that ready to go. And I got a clean white towel. Once my solder is on, I'll flow it around like this just to make sure it's wiped appropriately. So what I need to do first is I need to heat this to get this on. So I'm going to make sure that I've got a damp rag here so I can take this and grab it and move it on and wiggle this on once I heat this up. So the first thing I want to do is I want to heat up this section to expand that to get it to be synced in to where it's bottomed out. So in this case, because I want to do this fast, I could probably do this with MAP gas, but I'm going to use, since I've got the oxyacetylene out, I'm going to go ahead and use the oxyacetylene because this will be much faster because it's much hotter. So I'm going to get right to it. Alright, see that? See it going on? Alright, I feel like I'm bottomed out right now. That's what I was trying to accomplish. Now that I know I've got it bottomed out, I just touch it one more time with the flux. Make sure that's good. Now I've got my solder. I'm going to make sure the inside pipe is reasonably warm. And now I'm going to solder. Now remember, it's capillary action. It follows the heat. So I'm going to take the heat this way. Alright, that should be enough. Alright, let me shut that off real fast. And take this. And now with this white paper towel, I'm just trying to make sure that I'm all the way around. Now, of course, we're going to do leak tests here and everything like that. My black lines is pretty much lined up, so I'm good to go here. So that joint should be a good joint for me. Now I could take water and quench that down immediately, but you are better off allowing a joint, whether it be soldered or brazed, to cool down naturally. It will be a stronger joint if you allow it to do that. You could temper lightly just by kind of taking a damp thing like this and going over it. Just a, very that's more of a gentle temper rather than a big, you're spraying water or pouring water right on it, quenching it down really, really fast. So the idea is to let it to cool as slowly as possible. Now, alright, I've got both of these cleaned up. I made sure that I put this ring on first because you don't want to solder this on and not have this ring on. Then that will have been a mistake. I know Alright, so I want to put this coupling on here, but when you buy these at the Home Depot, they come with stickers, and I don't like those stickers, so I take a utility knife and I want to cut those off, because when I put my heat on, I don't want the sticker to be interfering with the joint at all. So I always remove these stickers like this with the utility knife, just to get the copper as clean as possible. Even though it's the inside that needs to be the cleanest, I just like my copper to be as clean as possible. Okay, so what's happening here is that this is giving me a really hard time, so I got it started, and what I did, even though this is a fitting, I reamed it out so that I could start the pipe going in, but it's still really tight. I don't want to disturb this because it's going to be mated, because it's a union. So we're going to hit it with the wood, which is kind of gentle, to try to get this to, and I got a black mark here to tell me when to do it. Go ahead. Ouch. Stop. Okay, so now the black mark is there, so I know that we're seated. So this technique with the wood worked, and it should not have disturbed this union, so I should still be fine on the other end. Okay, so I've got all my joints soldered up, and everything should be okay. I'm just trying to let it cool down a little bit. I'm still hot. Once this cools down, I can go ahead and do a water test here. So I'm just going to wait a few minutes to let it cool down. All right, while we're waiting for this to cool down, this is already cool, so I can go ahead and put these, the pressure reducing valve, I can put that back to normal in its new location, making sure the arrow is in the correct location. Okay, so now this is cool enough. We were putting the oxygen acetylene away. I can go ahead and connect this up here. And
quick, you got 1 bar.
And that there should, all right, so here, let's see here. I need to tighten this up here. And because it's a union, you're supposed to do the double wrench technique like this. Okay, tighten that up right there. Okay, we're nice and snug there. That's good. Okay, I'm going to go ahead and put my bleed ports back on for now. So that port is on. I probably already got this bleed port on. I didn't take, no, I took it off. There it is. Put that bleed port on. Right, that valve handle is slightly loose. let me just tighten that up while I'm right here. Okay. Okay, so that's good. This is tight. This is tight. I'm going to go ahead and shut this valve off here. And I'm going to shut off the irrigation. Now we're going to do our first water test of this system. Let's open this up. Oh, we got a leak. That one is leaking right there. This union is leaking right there. Alright, so let me see if I can't get this union tightened up here first. And then we'll address this joint right here and we'll see if we can't get that. So let's go ahead and tighten up this union. Let's try that. I still have a seeper here on this union, and then of course I still have that one. Let me break this joint here and make sure I've got it. Let me get rid of this pressure, and let me go ahead and open this up. Let's make sure that joint is clean. Alright, let me try that again. Try that again. Oops, let me shut this off. Alright, it looks like we got the union. The union's good. Now I do need to still get this one right here. Let me shut this off. And it's a soldered joint that I need to fix right there. Let me get rid of this pressure in the system. And I'm going to go ahead and open up my bleed. Actually, I don't need the bleed valve. I can just use this valve here. And I can get rid of the water with this valve. Okay. This one here, I got to redo this joint here. So this, I'm going to pull this apart. And I want to get this rubber O-ring out. So now that's a clean break. This is the joint that I need to touch and get that cleaned up. So let me get my flux and heat ready and some solder, and we're going to retouch this joint. And here we go. Actually, before I get into that, let me take a wet sock, because I don't want to disturb the rest of this. And I'm going to come back here like this, because I don't need this disturbed. All I want is this one joint disturbed. I'm going to do it like that. Okay. Try that again. So I heated it, I refluxed it, and I retouched it with the solder. I'm going to let that cool off as naturally as I can. I'm just going to wait a couple of minutes, and then we're going to retest it with the water test. Okay, so everything's cool. I've got that retightened up with the gasket. Let's shut off our hose bib valves here and here. And we're going to do another water test. Shut this off. Bleed valves are shut off there and there. And let's test. Ah, crap, I got a seeper still at the same joint. Ah, I got it really good on top, but I can see underneath it's not good. Alright, let me shut it down, and I got to break this again, and I got to do that joint again. Let's get rid of this water, and I'm just going to do the same technique again. Okay, the job is 100% complete. The leak that I had here, and I also had one on this union, are both stopped. I had to resolder this joint here in order to get it to stop leaking, but it's perfectly fine right now. I've got my pressure, my pressure gauges are on right now. So the incoming street pressure is about 120 psi. Go ahead and zoom in here, Mr. Cameraman. And after the pressure regulator feeding the house is about 65 psi. I didn't even adjust the spring tension. That's the same pressure that it was before. So the house isn't going to see any difference from the work that I just did. Now, this here is now energized with this pressure. The irrigation line is now pressurized at 120 psi instead of 65 psi. Let's go back in the backyard to zone 1 that started this whole project, and let's see how well zone 1 does now that we have changed the pressure and pretty much doubled it from 60 pressure to just under 120 psi. Okay, now what we're going to do is we're going to go ahead and turn it on. And there it is right there. Go ahead and zoom in over there, Mr. Cameraman. Alright, so here it is with the new pressure of 120 psi feeding the irrigation system. The ones that were giving us the really hard time was these ones here. They're better than they were in the past with the lower pressure, so this higher pressure is definitely helping out. And this is the highest pressure I can feed it anyways. It's the highest city water pressure I have here. So we're going to go for this and see how well this does irrigating the lawn. I probably still need to move that sprinkler head and that sprinkler head right there. Because, yeah, that one right there, that's right there, should probably go a little bit more over here. And I think I could get this bald spot that you can see right there a little bit better. Okay, so that's going to conclude this video. I hope there was some good pointers in there. An interesting thing about this video. Number one, when I was the one that did this job to begin with, and the reason why I put the irrigation system on the same pressure, 65 psi, is because from the research that I was reading, 65 psi was a good pressure for the irrigation system, but it seemed to be a weak flow, especially as you saw at the beginning of this video on zone 1 at the furthest point in the system. So increasing that pressure should be helping out my irrigation system and preventing bald spots. I even have a bald spot right here. Go ahead and come over here, Mr. Cameraman. So you can see I was even developing a little bit of a bald spot right here. So in me doing this job, it definitely has helped out at the back section as well as other sections on the lawn too. So anyways, that is why I did the whole job, trying to get that pressure better. I guess what the root question should be is, what is the proper pressure of an irrigation system? Now, when you go on the manufacturer's websites and everything, they're saying, you know, between 40 and 60 or 40 and 80 psi is appropriate, or something like that, going off the top of my head. At 65, I thought I was, you know, good. but the pressure seemed weak, and that's why I did that increase. Anyways, please click on like, leave a comment, tell me about your experience, what you think inappropriate. I would really like to know what the audience thinks, what the YouTube audience thinks should be an appropriate what should be an appropriate irrigation pressure. What do you people have out as set for your irrigation pressures? Please tell me and everyone else who checks out the comments on this channel. Please hit like, subscribe to my channel, Ken Training, and I will see you on the flip side.